Welcome to page 11 in your functions packet. In this video, we will be covering pages 11, 13, 15, and 17. We will be looking at linear equations as well as nonlinear equations. Let's get started. Let's start with linear. First of all, when you hear linear, I hope you think of the word line. Linear equations will produce a graph that is straight. It can be increasing, decreasing, or staying the same, but it will be straight. When you look at a linear equation, x will always be to the first power. We don't always write that, but it will always be to the first power. Now, let's start with linear and proportional. When it comes to the graph of a linear equation, we know that if it's proportional, it's straight and it passes through the origin, 0, 0. So the graph of that particular equation will look like that. Please take a moment and sketch the graph of that equation. The look of the equation will be something like this. Please write down these examples. 2 times x equals y. Now, we don't always write it, but we know x is to the first power. Or you may have a fractional coefficient like 1/4 times x to the first power equals y. Or even a decimal, such as this. Y equals 0.75, a decimal coefficient, times x to the first power. No matter how it's written, we know that that's a proportional linear equation, which will pass through the origin. But let's talk about the next type of linear equation, which is non-proportional. So again, when we graph it, we know that it will graph as a line, but it won't pass through the origin. Let's take a look at non-proportional equations. The graph of a non-proportional linear equation might look something like this, where the y-intercept is -3. And it has a positive slope traveling uphill from left to right. Or we may get a negative slope with an intercept of 4. But this is what an equation looks like when we write it for a non-proportional. 4 times x to the first, although we don't always write to the first power, but we know it's there, minus 3 equals y. Or we can have a fractional coefficient, 1/4 times x plus 2 equals y. And yes, on occasion we see decimals involved, such as 0.5 times x minus 1. All of those are linear, non-proportional equations. They will graph as a line, but they will not go through the origin. Please take a moment and copy down all the notes from section 1 and section 2 on linear proportional and linear non-proportional. When you're ready, turn on the video and we'll take a look at some non-linear equations. Pause the video if you need to right now. When we graph nonlinear equations, we get some very interesting graphs. You will be working with quadratic functions or equations, cubic functions, absolute value functions, and inverse functions. Each graph looks a little different from the other, and the equations are a bit different. We know we're not we know we're working with nonlinear. So the graphs will not be straight, and the x's in each equation will be a little different. You can see that in a quadratic, x is to the second power, and in a cubic, x is to the third power. Let's dig in and take a closer look. Let's start with a quadratic function. When you graph a quadratic, it will look something like this. A curved or cup shaped, known as a parabola. Please draw that in your notes. And when you see the equation for this particular function, x will be to the second power, and that will be the highest power in the equation. It might look as simple as this: 3 times x squared equals y. Or it might look like this: x squared minus 1 equals y. But when you see that x to the second power, you know that it's a quadratic. Now, the next type of function is a cubic function. When we graph a cubic, it will be an S-shaped sort of function. It curves, and it looks something like that. Now, you can get a cubic equation to look as simple as x to the third power, or you might get something like this: 2 times x to the third power equals y, or x cubed minus 4 equals y. But if the highest power is the third power, you know you have a cubic on your hands. Let's go to absolute value. I hope you remember the absolute value symbols. You can see them right here around the x. When you graph one of these equations, it looks like this. It is V-shaped. Now, the equation itself can be as simple as the absolute value of x equals y. Or you might have something like this: 2 times x, and we take the absolute value of that, equals y. Or you can have the absolute value of x plus 1 equals y. If you see the absolute value symbol in the equation, you know you have an absolute value function on your hands. And lastly, the inverse function. Well, this is an interesting graph. It is 2 curved graphs like this. Take a moment and sketch that in your notes. When you see the equation 1 over x equals y, you notice x is in the denominator. When you see that with an x in the denominator, you know you have an inverse function on your hands. Make sure you have all the notes down on this page. And when you're ready, turn to the next page and we'll take a look at some functions. On page 13, you can see that I've given you a graph of each type of function. Let's start with linear. Please trace this along with me. We have a linear function here where x is to the first power, and you can see it graphs as a straight line. The next is a quadratic. Please circle the 2 on the x. That is to the second power, and you can see that graphs here like this. It's called a parabola. Circle the 3 on the cubic equation. that is, trace this with me, that S-shaped graph. Then our absolute value function, which graphs as a V. And lastly, our inverse function, which graphs as like these little curved sections shown here. Turn the page and let's look at page 14 together and apply what we know now about the different functions that exist. You should be on page 15. On this page, you're going to take a look at each of the graphs that you've been given and determine whether the graph is a graph of a linear function, a quadratic function, a cubic function, an absolute value function, or an inverse function. You may use your notes from page 11 and page 13 if needed. For example, let's take a look at number 1. Clearly, it is that cup-shaped parabola. So if you need to look back, you can. Hopefully you remember that this is a quadratic. Let's take a look at number 4. That is that S-shaped graph. Which one was that? Well, that, if you remember, is a cubic function. So pause the video right now and put yourself to the test. See if you can determine what each of the graphs represent. When you've come up with an answer for each of them, turn the video back on and we can check your work together. But don't go ahead. Pause your video right now. Okay, let's check your work. For number 2, you should have stated linear. For number 3, that is the absolute value function. For number 5, we're back to that cup-shaped parabola, which is a quadratic. Give yourself a C if you got that right. These curved shape graphs go along with the inverse function. This straight line, of course, this is linear. Give yourself a C if you had that one right. And lastly, that V-shaped graph, absolute value function. Now, turn to page 17, and you're going to go through the same activity, but with equations this time. Please turn to page 17. On page 17, you've been given 8 equations. It's your job to determine if the equation belongs to a linear function, a quadratic, a cubic, an absolute value function, or an inverse function. For example, as we look at number 1, there's a few things going on. However, the most important thing, although we don't always write it, x is to the first power. So we know for linear, x is to the first. So we would write that this is the graph or the equation for a linear function. When it comes to quadratic, please take down these notes. The key will be x is to the second power. When it comes to a cubic, x will be to the third power. That's going to be the highest power in that equation. For absolute value, write this down, please. You're looking for those absolute value symbols. And lastly, for the inverse function, you're looking for x to be in the denominator of that equation. That will be the tip-off, indicating that it's an inverse function. Let's take a look at a couple more. For example, look at number 4. We can see there's a lot going on here, but the most important thing is x is in the denominator. We know that that means that this is an inverse function. Let's take a look at number 6. If you look at x in this equation, you can see that the absolute value markers are present. So clearly, this is an absolute value function. And lastly, take a look at number 8. 1/4 times x equals y. Well, although we don't always write it, we know x is to the first power there. So this equation would graph as a line. It is a linear equation. Now pause the video right now and answer questions 2, 3, 5, and 7 on your own. When you're ready, turn the video back on and check your work. Please pause the video right now. All right, let's check your work together. In number 2, this is the key indicator. It's to the second power, so we know that this has to be a quadratic. In number 3, we see x is to the third power, so we know that this is a cubic. In number 5, the key here is x is to the second power. So we know again that this is a quadratic. Give yourself a C if you got that right. And in number 7, we can see that x is in the denominator. Clearly, this is an inverse function. This concludes the video for pages 11, 13, 15, and 17.